Hi, folks. Hey. This is a Node.js meetup, so probably all of you use Node, right? OK. Thank you, by the way. I am part of the Node.js Technical Steering Committee, so we are all using some of the stuff that the Node Core project uses, and thank you for trusting us. I'm also a technical director at nearForm. We are a professional services company based in Ireland. It's we are about 140 on something. We are also hiring. So if you're interested in a job at the Node.js, full stack, whatever developer, I have cards with my business cards. So I have business cards, whatever. I also have stickers. So if you want to come and grab a stickers afterwards, I put the stickers here. So whatever, just so that you know. OK, so going back to the talk, a new way to profile Node.js. So I have been on a journey of making sure that Node.js is fast, OK? And I've been trying to optimize application and run application in production with Node for the last maybe 10 years. Let's say 9. 1 year, let's discount it, because it was not really production ready, OK? By the way, Node.js is 10 years this year. So Node anniversary is coming up soon. So anyway. And I put in production several pieces of code, several applications of Node.js. So how many of you have been on call? We have something in common. OK? So if you have been on call, if they offer you to be on call, say no. OK? But if you have to be, you will face some stuff like this. Somebody on a Sunday morning at 7 a.m. will call you, shouting at you, more or less, everything is down, nothing is working, and blah, 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 blah. OK? Happened a few times. Angry people are very angry most of the time. So it can be a problem, right? So what typically happens is that you don't lose your cool, and typically, you do about a magical thing. Let's tear it all down, tear it all back up. Everything works now. Hey, fine. That was quick. But the question is that you want to know what happened, right? And you want to understand what caused the problem in your application. And at some point, it boils down to if your servers gets down and they have a problem, and because there's a spike in traffic or something, it all boils down to answering a simple question: why it is slow? It is a problem, right? It's a nice question to ask. Why? Why did my server went down on a Sunday morning? OK. Why I couldn't sustain the traffic for Black Friday? Now, if that happens, you are in trouble, let me say. So you need to ask the question, why it is slow? Is it slow? There are quite a few ways to answer this question, really. But the main one is because bottleneck. And bottleneck has a nice property. Whenever you have a problem of a system in production that is not performing as expected, or you have a performance issue, a production issue, whatever, it's because you have a bottleneck somewhere. Essentially, the flow of data in your system gets constrained in a certain part. And things get slowed down to a point, to a crawl, and then you have a problem, right? It can be you hit a threshold in your database, and the indexes that you have added, they don't work as well anymore, or can be anything really. You can have a problem, and then these little bottlenecks somewhere can have ripple effects everywhere else, right? So the question is not why it is low. So in order to answer the question why it is low, you need to understand in terms of bottlenecks, right? So you can have an internal bottleneck in your Node.js application. Remember, angry people are angry. We need to avoid the on-call call in the future, because that's bad. So if you have a problem in your Node.js, the bottleneck is internal. And we say that your Node.js process is on fire. And that's it, really. And my process can be on fire. It's steaming smoke, and I'm burning electricity like no tomorrow. my bottleneck can also be, the bottleneck can also be external, right? Because, my database can be slow. And if the database is slow, it's something else that's on fire. That's the database on fire, right? It's the database guy fault, not my fault. But I am the one on call, so maybe there is a problem here. We need to ask the question is, where is the bottleneck? How do we find this? Now, there is a nice thing, and there's a nice property, that there is always only one that you need to find at any given time. That's the one that is constraining your application. So that's our only arm that that's the only thing that we can use, really. Now, there's a process to find those problems and to fix any performance, any production issue. So first of all, if you have a performance or production issue, whatever, first of all, you need to diagnose what's happening. So typically, we do this by sticking some diagnostic into our Node.js process. And you can use whatever service you want. There is a bunch. Some of those are open source. Some of those are private. Some of those are software as a service. Some of those cost a lot of money. Some of those cost less money. And you can choose in the wide range of, of things. And typically, this gives a coarse-grained output. And, coarse-grained in the sense that, oh, maybe this route is my problem, right? So we are over here. Now, this clicker is really cool. And we have over here, right? Now, once we have this, we have another next step to do. Because if we know that this route is causing me problem, this is the route that is causing problem, right? I'm getting too much call on this, and this gets all down. Now, I need to reproduce the issue. You cannot fix a production issue without reproducing it, unless rebooting all machines. But that's not really a solution, right? So there was an old bug in Ruby on Rails at the beginning where they needed to reboot every single server at 24 hours. Also, Node.js has something similar. So Node.js, back in the days, it was days of Node 0.8. It has a really bad bug that it was leaking 8 bytes for each HTTP request. 8 bytes. Took 4 people 3 months to find where. If you leak 8 bytes for each request, at some point you go out of memory. So that's a problem. You need to reproduce the problem. So you don't want to reproduce it on your live system, right? Don't try that at all. So after you have done that, well, how do you produce the problem? You typically use a load tester. Now, I built a lot of things in Node. I also built my own load tester. It's called AutoCannon. It's an HTTP 1.1 load tester. It's very similar to WRK or Apache Bench or any JMeter or whatever you have used. But it has a nice JavaScript API as well, so you can even script it and so on. I don't know. I wrote my own, whatever. And I typically use that to go and to reproduce the issue. And after I reproduce the issue, then I can also still use my diagnostic data over here, right? So I can still use my diagnostic issues, but this time I get a little bit more clean data, right? Because it's not the same thing in production where all the things are happening at the same time. It only have one single thing happening that is my load test. So I can actually reproduce the problem up to that specific. It's my lab. I can do what I want. So I can actually crash all my servers. It was so funny. Once upon a time, I was at a client, and they sent me, all the traces and stuff. And I knew exactly what their problem was. And I plugged into their guest network that had trouble in loading Gmail. It was so slow. I was able to get down from that network the full staging cluster. They didn't like me that too much, but whatever. Anyway, after we have done this, now, how many of you like coding on servers? I knew somebody was there. Okay, most people don't. So most people want to code on their own machines, right? So you don't want to SSH into a machine VI and do stuff. I use VI in my machine, so it's kind of the same, but some people find this a little bit tricky. So after you've done that, you want to code it, you reproduce it on your machine. So you move down from a server deployment. Also because from time to time we deploy things in those things called containers or whatever, kind of hard to log in there, modify the code, restart, and so maybe not. And after we have reproduced the problem on my machine, now the fun starts. I know what the problem is. I can reproduce it. I can reproduce on my production-like server. I can reproduce it on my machine. Now what? Because how do I solve my memory leak or database issue? What do I do? Well, I probably need some more data, because if at this point in time I couldn't still figure it out, I probably need some more help. I need to use, I don't know, a debugger or some other tool that I can run on my machine, right? You can also do a really, really good thing, which is walking the dog or stare at the screen for a very long time. A friend of mine takes very long showers. All works. Really, not really reproducible and teachable. Oh, how did you solve this? Oh, I walked my dog for 2 hours. OK. Yeah, maybe, don't tell your managers, right? So, and after all of this, you get a performant application, and you fix your problem. OK. Not really like something that, it's not really a process, right? There is something missing here. Because we can tap into some sort of data, but if I show you the data, you will see like, oh, OK. So we at nearForm, I've been doing this at nearForm for like more or less 4 years, more or less looking at what I call the metrics. So basically a full blob of text coming out of the Node runtime that will tell me what was happening in the Node runtime. Was not really readable for most people. It took me a couple of months to understand what was in there. And if you are in a rush and you want to fix your problem, you can't really learn that at that point in time. So we have started this journey at nearForm of building this thing called Node Clinic. And this basically takes what we have learned, and we package all this data coming from the Node runtime that it can be very chatty, and create some beautiful visualization so that you can use your visual brain. We are all animals, right? We evolved from detecting patterns, and we say, oh, that's a lion. Maybe I need to run now. Okay, so we grow. We went from there. Or this is, I can eat that. I can't eat that. So basically, use our image pattern recognition to look at things and see where problems are. So visualizations to the rescue. So this is Node Clinic. npm install -gclinic is a tool that you can run on your machine. We'll run this in a second. Clinic in reality is a bunch of subtools, okay? And the reason is Node.js is, depending on what is your problem, you might want to use different tools, okay? So we have Doctor, we have BubbleProf, and we have Flame. Let's go through them. So the first one is Doctor, and it basically, we run Clinic Doctor runs your Node.js process by injecting a bunch of probes. So we track the event loop cycles. So every time the event loop goes around, we track how long that takes. We track the memory consumption and the GC garbage collections that happens throughout the life of your Node application. We track the CPU usage, and we track the number of handles. Handles are the file descriptor, for example, the number of requests that are coming in, the number of files you have opened, and you can spot problems in there as well. And this is what you get. So basically, you get something like this, where you have a nice diagram here. But look at this nice part. So it automatically can detect stuff, detect a potential I/O issue. Now, how does that work? How can we self-detect problems? Well, we can, because there's a fantastic thing. It's called machine learning. So you feed a bunch of data, build a model, hey, or for some other stuff, you use some statistics. Don't try statistics at home, okay? Hire a statistician, feed him data, they give you a model, use that. It's kind of like machine learning, but whatever. Hi, Andreas, I love you. Basically, it gives you a recommendation. So it can detect certain class of problems and recommend your next steps. And it also a lengthy explanation on why that is the problem. Clinic Flame is basically a flame graph. How many of you have used the flame graph in the past? Some of you. OK. What is a flame graph? Basically, your Node application is running. OK. What does it mean? It's executing one function at a time, right? So an event comes in, some I/O, whatever, a request, calls a function, that calls a function, that calls a function, that calls a function. What a flame graph does? Every millisecond, there is another thread that pulls the stack of your Node application and say, oh, these are the functions that are being called right now. And that's, takes all of that. And then when you finish your observation, it computes, takes all that data, and generates a beautiful visualization that looks like this. So essentially, those are the stacks. So, and we'll see a little bit closer in a moment, actually. Yeah, no, we'll see it closer in a moment. So, final piece is BubbleProf. BubbleProf is a new visualization that we have built. It's a visualization of asynchronous activity. So how do you visualize asynchronous activity? How do you make them explorable? And that's what BubbleProf does. And it uses a thing called async hooks. How many of you are familiar with async hooks? No, somebody. You are here. Async hooks are a feature of Node Core. Don't try them at home. These are really advanced feature. You can essentially break your Node process if you use them run. But very likely in your Node.js application, if you use Node.js in production, there is some module in your thing that is using them. So if you want to do those fancy diagnostic things that I was talking about before, they have to use async hooks internally to do their thing. But we also extract a lot of data of all the asynchronous code that happens in Node.js. So what it means is I'm opening a file. Oh, I'm scheduling this thing to happen. So this is an asynchronous activity, right? Read file, a fast read file. Oh, I'm reading a file. Then the file comes back with the data. Now, this hop is what is happening, OK? And async hooks will be able to tell me that this happened, and we can tell how much time it lapsed between when it started to when it finished. So then we get all this massive amount of data, and we can plot it. Now, what is the problem? It's a lot of data. So it takes some time to process and collect all of this. And we generate bubbles. So again, we'll see this in a moment, but it generates a visualization that provides the asynchronous activity of your application at a glance so that you can explore it more closely. So essentially, with Node Clinic, we have where is the bottleneck. The question where is the bottleneck comes down to let's task Clinic Doctor. And Clinic Doctor will give us two recommendations. Can give us a recommendation to use Clinic Flame, or Clinic BubbleProf for the if it's an external bottleneck. Let's see how it works. May the demo gods be with me. Actually, before doing that, I need a beer. Cheers. OK, so I hope all of you can see this. I'm zooming in a lot. Can you read it from the back? Yay, fantastic. OK, so let's say that we have a tiny Node.js application. OK, it's called OneJS. And you can do, OneJS, if you call it, it will return a JSON. Now, you see that it's low, right? This is some data from NPM, by the way. So, you can see that this is low, right? Take some time. If you want, you can even use time to say it, take some time to respond. So, these are performed as a performance issue. So, how do you fix it? Well, first of all, let's see how fast or slow it is. Let's run some tests, OK? So we can use AutoCannon with 2 connections because this is really slow. And we can say, for example, for 5 seconds. Then you use this fancy syntax so that we can do a one-liner. So AutoCannon is built on Node, so we can do some fancy things with Node. So I can have my tool automatically run my server as well. So I have a nice one-liner for demos, by the way. OK, so the output got a little bit scrambled, so I need to zoom out. Sorry, OK. So this is the output, and it tells me there is a latency, some percentiles for latencies. Note that it's 1 second as a median, but 99 is 1 second and 1. But the problem is my median for the request per second is like 2 requests per second. 2 requests per second is not good in any kind of applications that you are building, okay? Ever. So this is a problem. So now we can use, let's clear this up. Now we can use Node Clinic, okay? How do you use it? Well, there is a clinic, this is an executable, and you can, say some stuff, test you stuff. But what we want, we can use Clinic Doctor. And we can, AutoCannon is really integrated also with Clinic. So what we can do is, for 5 seconds, 2 connections for 5 seconds on /, and then we run one.js. Take some time, we run our benchmarks. Hey, similar numbers. It analyzes our data. It's rendering, here we go. What you're seeing here is it tells you that it has detected a potential I/O issue. Some nice things here. There is a recommendation blob down here, and it says, Dr. Potential I/O issue. There may be some long-running asynchronous activity, and use Clinic BubbleProf to diagnose. Note that there is some explanation here, okay? And I'm not going through the explanation, but keep in mind that there is some piece of documentation to help you walk through it. So given that it tells you to use BubbleProf, well, what we need to do here, we just need to swap Doctor with Bubble. Now, I'm going to change one thing, because I'm moving from running, I want to move from running for a fixed number of seconds to a fixed number of requests. And it will become clear in 2 minutes. So I'm actually running 20 requests, which means 10 seconds, more or less, with 2 requests per second, whatever. But in this way, I can show you certain patterns on the application. So it's kind of useful when using BubbleProf to limit the number of requests that you are doing. So this is the visualization. So I hope you can see this. Okay? Can you see it from the back of the room? Yeah. Okay. So this is our visualization of the asynchronous activity at a glance. You can see 3 main bubbles, really bright. So we need to focus on those. Okay? But if you start at the beginning, if you open it up, it tells you this is the root node representing the starting point of your application. So this is where my application starts. Consider the fact that when you have an asynchronous activity, there is always a parent asynchronous activity and a follow-up asynchronous activity to some extent. Okay? So what it is, this first blob is basically starting up your node server, not really useful. And this is where we receive HTTP requests. Again, not really useful, because this is empty frames. This is node core. Don't care. Again, node core stuff. My problem, not yours. Okay? Then we can see that it forks. Now, if we open it up, if you open it up on the right side, you can see that this is basically, a bunch of things coming from MongoDB. Oh, this application is using Mongo. Okay, interesting. And it's taking some time from Mongo. Okay, not really useful. What is on the other side? And we go through why it forks in a second. So this, in fact, is actually splitting my things in 2. And you can see here and here. And you can see that on the first part, it says the exact line of code where this block of asynchronous activity is happening. Note that my application is spending 6.4 seconds just doing that asynchronous operation overall, over the time of observation. And this, it's on line 13. The second one is on line 13. So line 11, line 13. Now, if you look at this bar here, it will also show the patterns of the asynchronous interaction. Note that we can see that we have there is 1,266 calls to 1,000 asynchronous resources, which is another matrix of knowing how much asynchronous activity my application is doing. Okay, so we have detected that there are 2 my system. It's there is 2 activities that are taking a significant asynchronous activities that are taking a significant amount of time at line 11 and at line 13. So we can open up one.js, and we can see that we have line 11 and line 13. So this seems MongoDB queries, right? So what I can do is I can bluntly copy one query, and drop into my Mongo shell, go to my database, and then, did it wrong. And then just issue my query. OK, that's my query. I can also ask my MongoDB, to explain my query. So, and this tell me exactly what is happening. So my MongoDB is telling me that it's doing a sort key generator on the full collection. So every time I'm doing a query, it's sorting the full collection. Maybe I should just add an index, right? Oh, well. Seems somebody has added another database there, another collection, which has an index in place. So, I'll do it. So essentially, I can just swap my limit and see, oh, this now looks faster, right? It feels faster. And I can also ask to explain it. And with my index, you can see that there is IX scan, which is a meaning for index scan. So essentially, I'm using a database index for reading up my code. So, OK. I can change my application to use that, right? So, there is a magical, I can open up my 1.js file. There is the connection modules. And magically, it's module index now. OK? Now, we have the second file. So let's run bubbleprof with Stu.js, which is the second version of the thing. And let's see how it goes. Now, you can see that it took way less time. And it's doing like 20 requests per second, which what we are doing. Now, this is a very different layout than the one that we were doing before, right? And it's still doing the same amount of asynchronous resources, very, very similar to the one that we were doing before. However, now we can see that this block here has changed completely the shape, because it moved from being 1 second, 6 seconds and something, to be 370 milliseconds. So it means that my single slow I/O operation got way, way faster. We have this fork here because MongoDB uses a connection pool. So essentially, we have there is certain connection that stays alive forever. So, and this is why we have these things running for some time. So, OK, now, well, you see, we are doing 20 requests, and we are doing 20 requests per second. So maybe we are, we are not eating this and fast enough. So what we can do, OK. What we can do is that we can bump the number of connections to 100, right? And let's see how it goes. Live performance, whatever. Here we go. OK, it does 87 requests per second now on the median. Seems good, right? Is it good or not? I see you are in doubt. There is still some time for the talk, so that was the answer. The latency, though, is kind of bad. So if you see some latency that is this high, it's something that you still want to diagnose and debug. So what we can do now is we can run doctor again, right, with the same kind of parameters. So we run doctor and then see what doctor tells us. OK, now there's a completely different pattern from before. The event loop is blocking. And you can see this by this event loop delay. OK, so essentially, the event loop is blocking badly. Now, this is a problem, right? We don't want the event loop to block at all. So what is the recommendation for the blocking event loop? It says to use Clinic Flame. So that's what we are going to use. So instead of doctor, we are using Clinic Flame and to diagnose the problem. Here we go. Now, this computing data. As you see, this after data that we have computed, it will take some time to generate the things. Now, there is a fantastic mode here that I can click. So you might see this better. Now, you can see this. There is a line. So these are all my stacks. Can you see this? Can you see? OK. So you can see that all my application is divided by the dependency. So I can see at a glance which are the dependencies that are doing my things. And I can see that this is my demo. And I can see that I'm spending a huge amount of time on this compute magic function. Okay. Note that I have some other little thing in here, which is I can turn on V8. And now I can see exactly what is happening inside. Now, there is a built-in JSON stringify. Why compute magic use JSON stringify? Why the hell? At line 25, whatever, who wrote this code? Oh, OK. Nice function. It's doing something meaningful here. Essentially, somebody's computing magic, which is basically running, hashing the JSON things for some time, which is completely useless, right? So we can actually shift and remove completely that code because it's completely useless. Note that most of the time in enterprise software or whatever, code is lingering in there forever without getting refactored or removed or anything. So it's very often than not that there is code that is actually doing nothing. Anyway, we have removed it, right? So let's run it again and see if this goes fast or not. OK, here we go. OK, now I'm happier. The latency is low. At 99%, at the 99th percentile, it's 249 seconds. And I am, I can do at the median will be 1,000 requests per second, which is not good, not bad, but I can call it a night, right? And OK, so more or less these were the tools. Now I have some more things to say. So, but I need some more beer in the meanwhile. It's a meetup, it's night, and at the meetups, the talks are with a beer. So how can we improve the performance of our Node.js applications? First of all, we need to know how the event loop works. If we don't know how the event loop works, we are in big trouble. Otherwise, because we cannot really understand the interaction between the various parts in my application without knowing the internals of the event loop. So how does the Node.js event loop look like? This is it. Do you think this is intelligible? Have you ever seen this diagram before? How many of you have seen this diagram? Quite a few of you. OK. For the others, this long thing, this guide, took 6 months to write. So take a screenshot, take a photo if you want. If you don't, check it out. It's very important that you go and read that piece. It's a long explanation of all these phases. OK. The reality is, this is how libuv works. It's not Node.js. So the event loop for Node.js is done by a C library called libuv, and that's it. So this is a most nice picture, higher view picture of how the event loop works. So when we are running some JavaScript, we are inside like the big bubble, right? So when we are running some JavaScript, what we do, we don't do I/O in JavaScript. What we do in JavaScript is we schedule some I/O in the event loop. So we ask, oh, hey, event loop, please read me that file. Hey, event loop, open me a socket. Hey, event loop, write this, send the response back to the user, whatever it is. After it's done, after something is done, it goes back into the event queue. And with the event queue, things get over here. In the event queue, things are taken off this queue one at a time and executed in JavaScript. So we are running one thing at any given time. We also have a thread pool, if you see here. Hey, thread pool. Why? Not all operations can be done asynchronously. So unfortunately, we need to have some threads available for doing certain operations. Some of those are for the file system. So you might hit some problems with the thread pool. if you're doing a lot of file system operation, and you want to increase the number of threads available if you're doing a lot of file system operations. So going back to the life of an event, you have a JavaScript function that had a function as a listener for an I/O event. So you say, oh, call back that function when you are done. And then the I/O event happens, and then the function is called. Hey, that's it. So in Node.js, there's no parallelism of function execution. Only one function at a time, OK? For an event loop. Now, we will get thread workers. There are thread workers, but that's how many of you know what a worker is? Yay, fine. We can do that, but each worker in Node runs as a separate event loop. So essentially, all of this is still holds true. So there is no parallelism of function execution, only one at a time. Hey, so wait a second. Next tick, promises, and set immediate, my three good friends. Now, there is fake asynchronicity. From time to time, I want to create some asynchronous, something asynchronous that asynchronous is not. First of all, next tick. You have seen this in some demos, in some things online, called process.nextTick. What does this do? Process.nextTick, it's executed before getting another thing from the event queue. So going back to our events, everything that all the functions that I run with nextTick are run before the next event comes in. Essentially, it's synchronous, OK? But it's just fake asynchronous. There's nothing in the event loop happening at any given time. Then there are promises. Promises are executed after the next ticks. Why? I need more beers and whiskey, and we can open that can of worm later on. However, promises are executed synchronously. So if you do new promise and you pass a function, that function is executed immediately, but then it's resolved asynchronously. OK. Again, before any other I/O events happen. So you can. So if you do next tick after next tick, you can block your Node.js process forever. It's like doing a while true loop. And the same goes for promises. Set immediate, in fact, is different. Set immediate goes full circle. It puts another event inside the event queue, at the bottom of the event queue. So essentially, with set immediate, you can say, oh, call me when you have exhausted all the events that have been coming up since now. So this goes down to the hardest thing in Node. If you're doing Node.js professionally, if you want to do Node.js professionally, the hardest thing is to know when a chunk of code runs relative to one to another. So is this running before? Is this running after? If two requests comes in at the same time, what is run? Spend some time thinking about these things and trying, different combination. Console log is your friend, by the way, and see exactly how things interleave between each other, because you need to get familiar and avoid certain problems. And Clinic can help you understand all of this. Now, I have some more stuff. So, do you love promises, right? Do you like promises? Yes. Fine. I'm going to demystify it. Do you like async await? Yes. Yes. OK. I'm going to demystify a lot of that right now. So this is, do you all know about Promisify, right? Have you used this? Never wrap a promise by hand. Use that thing, OK? If you're wrapping a promise by hand, if you're wrapping a callback by hand in a promise, you are 70% likely to make a mistake, so don't. Use Promisify instead. So we Promisify set immediate, and we get sleep. Hey, so we can actually sleep for a certain number of milliseconds, and that thing will get resolved after that time has passed. So what we can do, we can use then, and when it's then, we can do rest.end to send a response, or we can send 500. OK, fine. By the way, always put the catch handler in your promises, otherwise bad things will happen. Unhandled rejection means a memory leak, so another kind of worm. But if you want to talk to me about unhandled rejection, get to me later. This is the bubble prop diagram of that thing. Now, this is interesting to see, because you can see that we have our HTTP connection comes in, then we have this blob, and in this blob, you know, it's forks. So it forks, but one of the two forks goes nowhere, right? So if you see here, there is this arrow. Like, this is not big contrast, so let me see if this other mode gives me that bit of, yeah, probably better. So you see this arrow here, right? Now, this arrow means that the execution continues. Now, this finishes here. And if we click it, we see that, you know, it goes into my application at line 14. Now, the reason why it stops, it's because it's what I was saying about resolving a promise asynchronously, right? So essentially, when I'm running my code, it forks when I do sleep. So when I do a sleep, in fact, it forks. Because there is an execution path that continues and finishes the function or the end of function. And then there is the then, what I allocate with then, that will be executed in the future. So that's what it means, okay? But it's still pretty linear, right? Okay. Async await. This is better than before, right? Do you like this better? Okay. Note that there is a catch handler. Always put a catch handler when you wrap, okay? Note that I'm not putting an async here. Never do that, otherwise you will get in big trouble because of error handling. You will basically introduce a memory leak, so just so that you know. And now we have this, our nice await and our rest end. So do you think that the bubble prop diagram will be the same as before? How many of you think it will be the same? Okay. This is it. Oh, I clicked the wrong one? Yeah, this is the wrong one. Sorry. Wrong image. So this is, wait, I did, yeah, this is the correct one. So essentially, this is different now. Why? And the reason is, you can see that there is more forks, right? 1, 2, 3. You can see that there is a lot more forks. Why there are a lot more forks? Well, the reason why there are more forks is because it creates more promises. So we know that an async function returns a promise, right? However, when we do an await, in fact, 4 more promises are created. OK, I've said it. We're cutting those down to 2 in the next version in Node 12. In Node 12, you will have only 2. So we are happy, kind of, about this. Just saying that there is, you know, even this is nicer, it costs more cycles. There is a nice talk, by the way, at NodeConf.eu last year by the team at V8 that explains all of this in more detail about this bunch of promises. And yay. So back to callbacks. We do a bunch of read files. This is callbacks, right? This is ugly. Can we all agree that this is ugly? Fine. This will appear exactly as it is, one after the other. Right? I don't know if you see where I'm going with the next slide. But this is with async await, which it's way nicer to read, right? But this is what it looks like in reality. This is how my system will look at my code. So this is my runtime. Look at see my code. So I am coding these nice await things and so on, but in reality, my runtime see all those different asynchronous interaction. Note that there is, you see this promise here that is from one frame from no file that comes from Node core. This is what is called a throwaway promise. So in async await, generate a throwaway promise just because the spec says so. Well, the new version of the JavaScript pack removed that, but for God's sake, But essentially, it's like this. Every time you do an await in Node 10, there's this appendix that's a promise that goes nowhere. That's what it is. And note that we can see 3 of them because we do 3 awaits. So it's 1, 2, and 3. Each one of them is next to a file system operation. And you can see that even the file system operation has more stuff in there, and so on. More promises, and more promises, and more promises. Note that you can see this scheduling tab here. You see at the top, this called scheduling in purple. And you can see that, all of this blob, all of this visualization is causing this much activity on in this group. So essentially, basically, we are spending a huge amount of my application. What my application does in terms of latency, it's spent just by calling those promises. This will get better, though, Node 12. So upgrade when it comes out in some weeks. Now, this is better because we are not calling await which one of them, but you're using promise all. So if things are not related to each other, you should always use promise all, because now you are parallelizing the asynchronous execution, the actual read file. Note that every promise is executed synchronously or solved asynchronously, right? So essentially, my promise is called immediately. That schedule an action, an IO action, and then I'm pasting the promise that I'm getting back into my promise all, and I'm awaiting that. So this generates something a little bit better for us. And you see there is like a butterfly thingy. And given that we are doing only on one single await, we have only one single little appendix there, that will go away in the next release of Node. So I'm actually happy. And so on. So some more time, some more performance considerations. So you have a slow I/O operation in your system. You might have a slow I/O operation in your system. This can happen at any time. Like the database can get into trouble. Maybe you are asking. This is actually a case that happens several times to various amount of companies. So you have a nice idea. I want to increase the number of the replicas of my database, right? So essentially, I spin up a new database, and then I attach it to the cluster, and then the data starts feeding from the other peers to the main ones. But the other peers were more or less at capacity, so they start slowing down the queries so they can feed the new replica. And so I have a slow operation out of a normal maintenance task. Now, in Node.js, you have seen that Node.js can be really quick in scheduling activity, right? So the event loop says, my JavaScript executes, the only thing my JavaScript does is scheduling something on the event loop. That's it. So it spans really fast, right? So essentially, and then it takes the next event from the event queue. So essentially, if I have a slow I/O operation, and if I send a huge number of requests, they will all get accepted very quickly. Because if I receive 1,000, it takes 1 second to reply to my database connection to my database query, and I receive 1,000 requests. More or less, my Node.js is not doing any processing really, so it's taking all those requests and transform them in queries for the DB. And then the DB says, and dies. Bye. So basically, our application increased the amount of concurrent tasks, essentially. Because basically, all of those requests are there, idle, waiting for something to happen. Wait a second. Those requests have some memory attached to them. Each one of those requests, how does it map? It's an object, right? We have a request and response. Objects in memory. Memory in the operating system to run my TCP sockets. So all of this memory, it's allocated for each of your HTTP requests. So, the memory consumption on my system gets up. So I see my memory blowing from 300 megabytes to 1 gigabyte in a matter of a minute. How many of you saw this? Like Node.js into 1 or 2 gigs of memory very easily. Now, when the memory goes up, what does it happen when those requests complete? Well, there is the garbage collector that needs to come and clean them up. Where is this garbage collector running? On your nice CPU, right? Now, there is this thing called Docker and Kubernetes that you're probably deploying your application to, that you can set the number of CPU allocated for each container. How many of those are you putting on your Node.js deployment? Is there somebody? 1. Yes, most people will tell you, put 1. If you put 1, if your garbage collection is passing its time in cleaning the stuff, because it runs on a different thread, right? You're not executing your code. So essentially, you are slowing your application down, even on the CPU side, by the amount of garbage collection activity that is happening in your Node application. So essentially, everything is loosely connected. So in Node.js, latency low throughput are more or less two sides of the same coin. You can't really get low latency, okay, without getting very high throughput. Those two things are the same thing to some extent. They influence each other. So let's close it up, wrap it up, because you probably want to get some more drinks. I don't know. I'll keep getting my beer. More beer time. So when you're doing any benchmarking, any activity, send some goal. Optimizing things, it's a never-ending task, so you don't want to loop forever. You want an exit condition. And whatever. Set 1, whatever it is. 1 request per second with 2 seconds of response time. I don't care. Set 1. Also, you can choose fast libraries. Just saying. One of the most, back in 2016, we were at a client, and they were logging so much that the logger was their bottleneck. Don't laugh. It's actually, there is a nice talk that me and my colleague David McClements did at NodeSummit 2016 called The Cost of Logging, and with actual numbers, and there is a huge difference. Logging is actually very costly because you are actually, you need to write stuff out and do some I/O on. That is an I/O activity, right? And so I ended up writing. We ended up writing our own logger called Pino. It's the fastest logger for Node.js that you can use. Check it out. Works very well. So we have been using it in production since then. It's phenomenal. After that, the other culprit, the second culprit of that system was the template engine. And well, we did some refactoring on how they were using their templates. Some insane marketing requirement, whatever. But then there was another problem, which was the web framework was actually costing us. We were losing throughput and latency due to the web framework. How many of you use Express? Yay! So I'm going to say something that you probably won't like, but I'm going to say it anyway. So let's say that on a Xeon top of the class server, Node.js can do 70,000 requests per second, right? A tiny node, the same type of Express server, can do tuned for production and performance and throughput. So already, with some configuration, can do only 38,000. Basically, Express is cutting your maximum throughput in half just to exist. And the more middleware you ask, it gets worse. So I ended up, again, I keep inventing things. I ended up in all the possible places. So I ended up creating a community to build a web framework because it's not building a web framework. It's too big for a human being. So you need a community. So I built a community. I grew the community. And we are about 12 people maintaining and writing Fastify. It's a web framework for Node.js, currently a version 2. So anyway, check it out. I've been demoing all of this tonight, so you probably have seen it in place. Node, by the way, I have Fastify and Pino stickers if you want them. So there are the stickers there. It's beware of the rabbit hole. 80%, again, the 80-20 rules still apply. So don't leave optimization to the end. If you're building an application for an e-commerce, for example, I'm currently architecting an e-commerce application. If you're doing an e-commerce, okay, you don't want to do your load test 2 days before Black Friday, right? Or Cyber Monday. You know, that's saying for you. You need to find out what fast enough means, because if you're building an e-commerce application, it needs to go fast. If you're building a software as a service that will be an internal portal for 10 people, or 50, or 100, or 1,000, who cares? Can be slow, okay? It's fine to be slow. And also, your time costs money, so you can optimize the servers or you cannot do work. And both those things, your management will be very wary of the trade-offs. Remember that you don't have always to reach ludicrous speed. So don't end. If this is a quote from Spaceball, so if you don't get it, go watch Spaceball, and somebody got it, whatever. So if you need any help for your Node.js application, it's nearForm. We are kind of in business. We are also hiring. Okay, so if you want to work on Node.js, on React, if you are into DevOps, I don't know, ping me at Matteo Collina on Twitter, or come talk to me after this. So hey, if you're looking for people. We need to hire 40 in Europe and 40 in the US in a month. So just saying. It's full remote, by the way, so whatever. Yeah, I think it's question time. So I ended up more or less mostly on time. So
you talk as long as you want.
Whatever. Are there any questions, or you're too late for this type of depth after a few beers and some pizza? Have you got a question?
How fast can Fastify go against the Node.js?
72,000.
Well done.
The Node core was 70, by the way. And then we can tie. That's another hour for those. I cheat. So truly, any questions? Yay.
When is Node.js getting tail call recursion?
Sorry?
When is Node.js getting tail call recursion?
Never. JavaScript didn't get it. Wrong answer, yeah. There is actually, at some point, there was a flag where you could actually turn it on, but don't try it at home. The problem with that tail recursion thingy is, so it's still in V8. For example, if you are doing JSON stringify, if you use JSON.stringify, the algorithm that does that use tail recursion optimization by the V8 team. But they have some special magic to do it that you're not allowed to use, essentially. Thanks, folks. No, TC39 ruled it out, so it's not going into the language, so the VM vendors are not getting that in. So I'm sorry. Probably wrong answer, but there was another question here.
So what were the extra promises for in async await?
Hmm?
Why are the 2 extra promises in async await? What are they for?
The forks?
Yeah, the extra promises. You said there's.
Yes. Okay. So let's say like this. So you are you are awaiting on a promise, right? Okay. So when you are in a, so you enter an async await and you are in a promise, right? So you do, if you want to await on something overall, what you will write, if you write it by hand, you will do a then. That's another promise, okay? And we are at one. However, the async await up until last summer was not really working on promises. We're working on thanables. How many of you know what a thanable is? Somebody knows. OK, so what is a thanable? A thanable is a generic JavaScript object that has a then method that accepts two functions. That is the base contract between promises. So essentially, if you create an object, attach a then method that accepts two functions, you could use that and await on that, and have the then method being called by await. This is the mechanism that supports you in, for example, using Bluebird with async await. You can take a Bluebird promise and put it async await, and it will work because there is this mechanism. However, what this means, async awaits, what it does, it takes a thanable and wraps it into a promise. And then, when that's finished, it schedules a promise reaction job, which is another whatever weird name, probably longer. I mess it up all the time. That actually has when the thanable finishes, has the responsibility of resolving the parent thing. Essentially, a lot of promises work. What they've done is they've done a shortcut in the spec. So they've said that if you use native promises, essentially there is no need for all of this dance of wrapping stuff. You can, they will actually avoid scheduling these promise reaction jobs and all these things. So essentially, they will just use the native promise internally. And by how V8 works, it will just get more or less optimized away. So it will be really, really fast. It's also the same thing that if you the Node.js 12 will have asynchronous stack traces. So if you do async await, it will show you the exact asynchronous stack trace up until you have done await so far. And this is possible because of removing that piece. So it's pretty cool stuff. I hope it was more or less clear. There is this talk from Benedict Mauer at NodeConf.eu last year. Check it out because it's really it's 25 minutes on this problem. It's a long one. They spent, I think, 6 months working on it in 2 people, so to fix this. Bear in mind that NodeConf.eu tickets are on sale. So if you want to come, I'm part of the team organizing NodeConf.eu. More stuff. We are also looking for speakers. So if you want to, try your luck with the call for proposals, and if you have some questions about that, please reach me out so I can, help you out if you want to. Yep. Any more questions? I'm drinking beer. So.
I think you just answered every single question people might have, by just giving this talk.
I don't know. I melt everybody's mind. It's probably more close to that. Anyway, if you got some questions tomorrow, tweet me and I'll try to get an answer. Also, if you go to clinicsjs.org, there's a bunch of docs. So if you want, you can check them out. The example that I've done in the talk, it has a full walkthrough with all the explanation. So you can open it up, clinics.js, and there's even a video of me talking. And by the way, this is a nice Gatsby application. So if you want to play, and there is a bunch of things and some explanation of stuff. So and note that you can clone the examples as well, whatever. And everything is open source, by the way, so you can play with it, do with it, fork it, do whatever you want. So I think thank you.